Jai Hind. I am Madhup Agrawal, Assistant Professor in IT Department, AKGEC Engineering College. Today we will see the different operation just like traverse and insertion operation in the singly linked list. As we know, singly linked list is a very useful data structure in the computer science field, and this is the main topic of data structure subject. So we will study or see. First, we will see what is the linked list, as we already know, but we will see here. Linked list is the connection between different nodes. These are known as nodes and connected within, just like in the form of just like a train or in the series, in the linear fashion. These are connected. Before the linked list, we use the array. We use the array to keep the data. But what was the problem with the array? If we want to keep a large amount of data and we have no space in the memory, then how to tackle this problem? So this is the solution for this particular problem of the array, singly linked list, or simply we know a linked list. So in the linked list form, we keep data and then link part in a single node. Data part and link part in a single node. In the data part, we keep the data, and in the link part, we keep the address of next node. In this manner, we traverse one by one up to last node. From where we start? We will start from the first node, and the address of the first node, actually these are the dynamic memory allocation. By the using of dynamic memory location, we get the address of each and every node. Just like example, if we allocate a first node and we get the address of the first node, just like if we guess this is 1000, so we keep this particular 1000 in the starting node, starting pointer. This is a pointer, just keep here 1000. So this will point to the very first node of the linked list, and in this manner we kept here. What will be kept here? Here we kept the address of the second node. Let address of the second node is 2000. So here the value is 2000. That is the address of the next node. And already keep any data for suitable for this type we kept here. And in the third node, we kept the address of the next node. Let this is 3000, and we keep here 3000. Okay. And here no next node here, so we will keep the null pointer. No address, so we keep the null value. So how to traverse? First, traversing. So just we can guess here 1 minute. If this is, that case this is data 1, this is data 2, this is data 3. Then how to traverse? With the help of this starting node address, which is kept in the start pointer. This is actually, what is this? This is a start pointer. This is a pointer, linked list pointer, which point the first node of the linked list. So now traverse. We have only the address of this particular node, that is 1000. In hand we have only the address, this address. So first see the 1000, go to the 1000 location in memory, which is the very first node address. Then we will access the data part. As per requirement we can access. After accessing we can modify, update, or as per requirement just traverse or show or display, anything we can do. So this is the data part, this is the link part, each and every node has data part and link parts. This has already data part and this is the link part. This have the data part and link part. So traverse. Now traverse. With the help of a start pointer, we go to the very first node. In the very first node, we access the data part. In the data part, we kept the data 1. So if you want to display, so display data 1. Now move further. Move to the next node. How to move the next node? With the help of link part of this particular node. Link part of the very first node. In the link part, we have the 2000. This is a 2000 is a pointer. Means this point to the address of the next node. So in the memory, we can jump to the 2000 location. At the 2000 location, we have two parts, data part and link part. We can access the data part. In the data part, we have the data 2. So if you want to display, we can display here data 2. Data 2. We are traversing here. So now how to go to the next node? By using the link part of this current node. The current node address is 2000. 2000 at the address 2000, at the link part of 2000 we have the 3000 address. This is the next node address. We can jump to the next node address, that is 3000. At the location 3000 we find the data part. In the data part we have the data 3. We can print or display or may perform any other action. So we can access data 3. Now we will move further. For moving further, we can access the next part or link part of this particular current node. In the current node next link part, we have the null value. No address is there. So what is the means of this? Means we have already reached to the last node of this singly linked list. So with the help of this particular null value, we stop here and we find the all the data part and traverse all the data from starting to the end node. This is the actual mechanism for traversing, and this traversing mechanism we can see here with the help of algo. So just see here, we are traversing singly linked list SL. So data and link and the start. So in the very first step, first check list is empty or not. It may be position that start pointer is here, start pointer having no connection further, maybe no node there. So in the start there must be the null value. In the start, if no node, if no any node connection, then there must be null value. This may be there. So first we check if start equal null, means no node is here, no connection is here. So if start equal null, then what to do? Just display list is empty, no node is here. Now and go to step 4. What is step 4? Just end the traversing because no node is there. If this not happen, means in this situation having some node connected with the linked list, then what to do? Just ptr equal start, just assign the ptr equal start. Just see here, we make a pointer ptr to the value of start. In the case start having the 1000 value, 1000. This PTR is useful for traversing because during the traversing phase we must update this PTR one by one. So with help of this PTR we will move. So this is a temporary pointer or variable. Yes. And repeat step, next step 3, repeat step A and B when PTR not equal to null. Repeat the step, this one, PTR not equal to null. What is the means of PTR not equal to null? At last, PTR will find this particular null value. First time PTR located this value. After performing the operation on this particular node, we will move the PTR here. Then after performing the operation in this particular node, we will move the here. And after performing the operation on this node, we will move here with the help of this null. But with the help of null, no node is there. So we will stop here with the help of this particular null pointer. So this is the null value. So perform these two operations until PTR becomes null. So display PTR information. Information part. This is information part. This is link part. So in the information part, just display the information part. PTR information. 1000 information part. Information part. In the information part, we have data 1. And what to do next? Just update the PTR. Update the PTR with the PTR link part. Just see here. In the PTR link part, just see here, PTR link part, we have 2000. Now update this with the 2000. Now in the 2000 position, repeat, we will check this 2000 not equal to null. Yes, true. Then what to perform, what to do? Just display the PTR info part. In the PTR info part, we have PTR info, means 2000 info part, we have the data 2. So display it and update the PTR value. PTR with the help of PTR link. In the PTR link part, we have the 3000. 2000 link part, we have the 3000. So update here 3000. This is not equal to null. So we must repeat these two steps: display and then update the PTR. Display the information part. In the information part, we have data 3. Display and update the PTR with the link part of this particular, that is null. Now update this with the help of null. Update this. This become here. We can write here. This is null. So in the while PTR not equal to null, now PTR become null. So stop here and come outside this step number 3, that is step 4, and the process. So we have displayed all the information from starting node to the last node. This is a traversing mechanism in the singly linked list. Now I think this is clear step by step. Singly linked list insertion. Now the second operation, very useful operation, insertion in the singly linked list. There are positions where to insert. We can insert at the beginning, we can insert at the last, or we can insert in between as per the requirement. So first we will see insert as the first node, means starting of the linked list. Now just see here. Before inserting the node, we must create a new node. We must create a new node with the help of the dynamic memory allocation. Yes, help of, and kept the address. Let the address is 4000. Address of this particular node. Address of this particular node into here, that is 4000 here. So how to insert? First see the scenario here. If this is a linked list, as we have seen, start, let the address of the first node is 1000, here 1000. Now we want to insert this, we want this particular new node into at this location. So there are many few changes here. What are the changes? How to do it? Just after inserting this node at the beginning, there are two connections must be changed. Just see here. This first node, this is the data part, no problem. We must fill the data part of this particular node, and here the address of this second node, this will become the second node and this will become the first node. the address of the second node here. Address of the second node means the address of this one. Address of this is here, that is 1000. So 1000 is the starting address, start address. So we will keep the start address here, that is newly created node. We will assign the link part, at the link part the address of newly created node here. Keep here this one. Now, so this will create a link in this manner. Now the first node address will keep here, that is 4000. 4000 we will update. This link will be destroyed and a new link will be established to this newly created node, that is this one. So in this manner we can insert a newly created node at the beginning position or starting position of the linked list. Okay, now we will see this scenario, whole scenario, with the help of algorithm. Just see here. Now again same, insert at the first place in the singly linked list, start data link PTR items are here. First check free memory is available or not, because we must create a new node. If memory is not available, then how to create? So first we will check memory is available or not. If not available, then discard. No, we cannot insert, sorry. And if available, memory is available, then what to do? Just allocate new node from the available memory. We will allocate a new node and assign address into the pointer PTR. Just again we will see here, we will create a new node, okay, having two parts. One is data part, link part, another is link part, okay. And this will have some address value. Let address is 4000, and we will keep this 4000 address at the PTR pointer. Means step, this is something like this. Okay. This is step number 2 assigned, 1 executed. Now step number 3, insert item in the data field of the node. Means here, first fill the data part, PTR data equal item. Item supplied here, we will keep here the item value. Just read, let item, okay, fill. Now insert new node as first node. New node as first node means PTR link. In the PTR link part, we will assign the start value. Just in the case the start value was 1000. So we will keep here 1000. We can make here also start 1000, and we have 3 nodes here. Here connection, now address 1000, here 2000, this having the address 2000, this having the address 3000, this is null. Okay, so we will keep 1000 here. Means PTR link part equal start. In the PTR link part equal start 1000. This is ready. Now start equal PTR. Just in this part, PTR link equal start means we have a connection from this starting location. Now start equal PTR, start equal PTR. Now update this start with the newly created node, that is 4000, means destroy this connection and establish a new connection to the location 4000. 4000 is here, location 4000. So this. Okay. So now we have the start pointer having the address 4000. 4000 means this is the our first node. Now this is the first node. Now second node we can access with the help of link part of the first node, that is the 1000 location is node is here. Then go further in the same manner. So in this manner we have insert the node at the first position of the linked list. Okay, this is clear, I think. Now insert the node at the last position of the linked list. Now how to do this? Very much similar to the first one, but we must traverse up to the last node, then insert, then perform the insertion operation. So create the new node, fill the new node, okay, then assign the address. Now newly created node become the last node of the address, and we know last node of the linked list having last node address part of the linked list having the null pointer. So we can prepare here in the same manner. Case 1, when list is empty. List is empty means simple, start having the null. As we have already seen, start having the null means no node is there. So in this case we will create a new node having some address, let's 1000, keep here the item, assign here the as a last node, so every last node having the null value, and assign this 1000 address to the start location here, and we will, okay. This is the scenario when start having the null means no node is there, means list is empty. We can say anything. Now step 2, when list is not empty, then how to do? List is not empty means if the list is in this manner and we are going to insert a newly created node at the last position. So just see in the here we can have, we have 1000, here 2000, the address of this is 2000, here 3000, and this 3000 address is kept in the previous node, and this is last node, okay, in this manner. So at the last node let this address of this node is 4000 is kept in the PTR pointer and null here. Just we are preparing the new node to insert at the last position. Now we must traverse from starting position up to the last as I have seen earlier, and after reaching at this point we must insert this node at this particular position. Then only one change is required, that we keep this particular address of the node 4000 to the here. Means if we keep the 4000 here, then the address of the next node become this. This will become the now newly created node become the last node. Very simple. So you can see with the help of this one. Insert, first check free memory is available or not as before. If available, then allocate new node available memory and assign the address into the pointer PTR. Same manner, this is the PTR, and we have created a new node having the address let 4000. We have the assign here 4000 and something like this. Okay. Now step 3, insert item. PTR data part, we fill the item here, item. Now when list is empty, we have seen if list is empty, then we must update the start. We must update the start with the PTR. Okay, and PTR link part equal start means that is already null if list is empty, and stop the process, go to step 6. And if not empty, main case is not empty, then traverse the list. When list is not empty, then traverse the list until last node. How to traverse? We have seen the traverse mechanism before that. with the help of this particular null. Temp equal start, and updating the temp, we are updating the temp with the link part of the temp, current temp, till the link part, temp link part not equal to null. We can see here, we can update the temp, until the temp part of the PTR not equal to null. So here not equal to null, temp part. Now move the temp part here, not equal, next part of the temp not equal to null. Okay, now move further, now temp here, now next part of the temp is before updating this one was null. So stop here, stop the process here, means temp will indicate at the last node after exit from the this particular while loop. So this particular temp here at this position, temp will indicate at the last node. So in the last node we will updating the link part. So link part of the last node become the newly created node address, that is PTR, and we have already assigned this particular PTR because this is last node. So the last node address link part is null, so we kept here null and end the process. So with the help of this particular scenario we can insert. Now in the same scenario, if position is given, position at this particular position, 1 position, 2 position, and so on, nth position, so we must traverse the n location further. In the previous case, at the last we traverse the last position up to last position, but in the case of this position we must traverse and counting 1 step, 2 step, 3 step, how much position is given there we must traverse. So if position equal 1 means that is empty node at the starting position. Starting scenario we have already seen. If position is greater than 1 means in between, first we check in between within this scenario. If maybe there are 3 nodes and we have given the position number 6, then there is no possibility to insert. Then tackle this also in between first position, second, third, fourth, and so on. So to tackle this, first check free memory is available or not. Then if available, allocate the newly created, assign the PTR in the PTR just like before. This is 4000 and we have assigned here 4000. This is the newly created node and this is the PTR. Now fill the PTR with data part of this one, data part with the item, and when position equal 1 means insert at the first position. Same logic here, PTR link equal start and start equal PTR, just like before. Now fourth way, when position is greater than 1, then what to do? Temp, assign the temp for used for the traversing, as in the used in the insert at the last position. And here a new thing is L equal 1. L means location equal 1. Then we are updating the location with the location L plus 1. And how many times we are repeating this? Till the position up to position -1. Means if you want to insert at the third position, then traverse up to second, and at the second location, just in the figure, if you want to insert the newly created node here, we must traverse the location 1, then node 2 up to, if L is 3, if position is 3, then up to 2, then insert at this point. So only what to do? Only assign this address to the newly created node here. Means a link, if this is having the address 3000, now assign the 3000 here. So a link is created, and here the just like if the newly created node having the address 4000, so update the link part with the, so we will this will destroy this particular link and create a new link to this particular node, in between. In this scenario, same scenario, so we are going to update and we are traversing up to n minus 1 position or position minus 1 locations. We are updating the L and inserting with the help of this particular logic. Same temp not equal to null, then update the PTR link part and temp link part. Two updations are there. So I think this is clear. Okay, thank you, thanks a lot.